Alright, we got a relatively fast one today. We'll be going through a bunch of stuff related to parametric equations.
Mm-hmm.
So basically using velocity and acceleration vectors or their components to figure out position. So that's displacement, velocity or acceleration based on other information that they give us, slope of an equation, equation of a tangent line, or values for the path of the particle.
Mm-hmm.
Okay, so before we jump into this, we've got three main equations for parametric equations. What's the arc length of a parametric equation?
Oh, that's d r over d theta square and then square plus r square and then square root.
Okay, so I think you're talking about a polar equation.
Oh,
Parametric equation is going to have two functions.
oh, dx and dy. No, dx and dt.
Y of t and x of t.
Mm-hmm.
Okay, so I've got two functions, y of t and x of t. Um, then my change in length over time, I could relate here using Pythagorean's theorem, and then I would need to integrate that. So what would my arc length end up being?
Y prime. Y prime square plus x prime square and then square root, I think.
Okay, so that would be L prime.
Oh, yeah. Then just y square plus x square square root.
Okay, so if this is L prime, then the integral of L prime should give me L, right?
Mm-hmm.
So I'm going to have to integrate this side as well.
Yeah.
Okay, so here's what it looks like. Actually, can I just erase everything? Um, so our arc length is going to be our integral from a to b of the square root of dx over dt squared plus dy over dt squared dt. So that's the same thing you were saying. We're going to use Pythagorean's theorem and then solve for dl over dt, then integrate from a to b.
Mm-hmm.
Okay, so again, if I've got a yt and an xt, how could I find dy over dx?
Oh, so you integrate both. No, you differentiate both sides. No, I mean y and x in terms of t, and then you just um um write it dy over dt divided by dx over dt.
Cool, dy over dx is equal to dy over dt over dx over dt.
Mm-hmm.
Okay, that looks good. What about the second derivative?
Oh, so you derive the first derivative. No, I mean dy over dt. Just derive it and then divide by. No, I mean yeah, and then divide by dx over dt.
I'm going to derive this in terms of what variable?
X variable
Not x.
t. Yeah, t.
Okay, I'm going to derive my first derivative in terms of time. Okay, then I can divide by
dx over dt.
dx over dt. Okay, cool. So write that out again. So look like this. So our first derivative, we're just dividing the dy over dt over dx over dt. For the second derivative, we derive our first derivative, dy over d. I think I've got a mistake here, actually.
Hmm?
Oops,
Should be dx.
that should be dx, right? There we go. Okay, so derive dy over dx in terms of dt, and then we'll divide by dx over dt.
Mm-hmm.
Okay, cool. Any questions on equations?
No.
Okay, so we've got 2 free response questions to finish. If you can't see for any reason, again, just swap over to the documents, either on WeChat or Skype.
Mm-hmm.
Okay, so I'm going to start with this racetrack one, or roller coaster rather. So we've got this path traveled by a roller coaster from 0 to 18 seconds. The position can be modeled parametrically with these 2 equations, x of t and y of t, where x and y are measured in meters. Their derivatives are given here. The first thing I want to do is find the slope of the path at the time t equals 2. So what would I have to do to find slope?
So we derive the x and y.
Okay, so the slope of my path should be my dy over what?
dy over dt over dx over dt.
Right, okay. dy, oh,
Mr. Brandon,
yes.
so we come to school. You're not coming on January 18th, right?
Not anymore. So the Ministry of Education has closed us off for the rest of February.
No.
So we'll be doing this through the rest of the month, at least. If they need to do longer than that, then they'll tell us later.
Do we have e-learning class like this?
Yep. So for the rest of February.
No.
And it's not ideal for us either, but we'll make it work. Okay, so this is dy over dt, which was 20 minus t times sine t.
Mm-hmm. Hmm? Oh yeah, it was given. Oh.
It's cosine t minus 1, and then 10 plus 4 cosine t. Okay, we need to find this at t equals 2.
Mm-hmm.
So dy over dx at 2 would... We're just going to substitute 2 in. Okay, if I plug 2 in, what do I get?
It's 18 sine 2 plus cosine 2 minus 1 10 plus 4 cosine 2.
Okay, so this is a with calculator one, so I'm going to jump in. I have copied... Jump back up here to show you what I've done. Y1 is currently xt. Y2 is yt. X prime
Mm-hmm.
t is y3, y prime t is y4. So I need y4 at 2 divided by y3 at 2 would be dy dt over dx dt. Okay, so if I want to do that, I can hit variables, y variables, function. Here's y3, so that's my, oops, sorry, y4. My y prime at 2 divided by variables, y variables, function y3 at 2 to get 1.793.
Mm-hmm.
Do I round up or down? Round up. Okay, so that's my slope. Do we need to do anything else there? Okay, any questions on part A?
Nope.
Cool. Part B, I need to figure out the acceleration vector of the car at the time when the horizontal position is at 140. What would I have to do first?
So, we derive again y prime and x prime.
Okay, so that would give me the components of the acceleration, which I could use to get the vector.
Mm-hmm.
But I need to get the time first before I can plug into that. So how do I get the time?
So horizontal position at x. So we plug in the number in x variable. No, I mean that should be xt.
Okay, so 140 is equal to 10t plus 4 sine t.
Yep.
Okay, cool. So let's do that really quick. I've got up here, y1 is 10x plus 4 sine x.
Mm-hmm.
And it does look like my x value goes all the way to 200-ish, so I'll have to change my window a bit. I'm going to make this y5 equal to 140.
Mm-hmm.
Okay. So, window. My y value right now is showing my x, so this needs to go up to 200.
Mm-hmm.
And then my time interval is 0 to 18.
Mm-hmm.
So here's our graph. And the point we need. How do I find that point?
Intersect.
Okay, second calculate and intersect. First curve, second curve, and a guess.
Mm-hmm.
Okay, so we've got our time. I'm going to hit second quit and then store that. X store as alpha t for time. Okay, and then I need to write what we just did.
Mm-hmm.
So zoom out a bit. X is 10t plus 4 sine t. So we said
Mm-hmm.
that equals 140. And if that's true, then t was equal to 13.647.
Mm-hmm.
Copy a couple more numbers. 08271. Okay, then he told me I would need to derive both of these. After I derive them, what do I do?
And then you plug in the time.
Okay. So I'm going to do y prime prime at, I'm going to call this TA. Y prime prime at TA.
Mm-hmm.
I'll get that value. I'll also get the second derivative of x at that time. And then what do I have to do to them?
So we just plug in the numbers. We derive it.
Derive it, plug in the numbers. Okay, so here's y3 is x prime, y4 is y prime. So I'm going to do y4 first.
Mm-hmm.
Math 8 is a derivative. We are going to derive our y4 function in terms of x at our time t
Mm-hmm.
to get a number. 1.225733.
Mm-hmm.
Okay, and we'll do the same thing for x. Negative 3.52917. I should have stored those values. Okay. Store as alpha b. I'm going to go back and do my y's again. Okay, store as a. Okay, then our final answer. So our acceleration vector. Oh, we actually don't need the slopes. I guess I don't need to save those, but my acceleration vector would be what?
We use. Oh, that's just minus 3.53.
Okay, so my x, negative 3.529, and my y.
Yes, 1.225.
Okay, this should go 1.226 to match the other one. Okay, cool. Any questions on A or B?
Nope.
Alright, part C. I want to find the time when the car is at a max height, and then find the speed at that time.
So, at maximum height, that's when first y derivative is equal to 0.
Okay, cool. So let's set that equal to 0. I've got my y prime here. Uh, 20 minus t sine t. Okay, so we set that equal to 0. And solve for y prime. So if we do that here, our y prime is y4. What should my window be in order to see this?
I just do zoom 6 or zoom 9 or zoom 0. Not 6, maybe 9 or 0. Fit, yeah, zoom fit. Yes.
Okay, so taking a look at the graph, I need the first time when we hit 0 after 0, right? So that would be here. So second calculated 0. My left bound, I'm going to say 2-ish. And my right bound will be down here, below that. Okay, so our 0 is at 3.0239. Second quit, and I'm going to store that value again. Okay, that is C. Okay. T equals 3.024. Okay, so that was the time we're at a maximum height. And then find the speed at that time. So how can I find the speed?
Speed, that's square root d prime t square plus d prime y square.
Cool.
Huh.
So our speed would be that. Okay, so now we just need to go in and plug in those values. Let's see, I'm going to do square roots of variables, y variables function. Here's x3 is x prime at our time.
Mm-hmm.
And square that. Plus variables, y variables function y4 is y prime at our time. And square that. Oop, I need one more parenthesis there. Okay, gives us our answer. So our speed is 6.028.
Mm-hmm.
Okay. Then we're told that we have 2 times where the car is at ground level. I want to find those 2 times and write an expression that gives the average speed between those 2 times. So what would I be looking for if I want to know when this is at ground level?
Ground level. Uh-huh. Wait. Oh, y equals 0.
Okay, so we'll put those in. So I'm going to graph my y equation. This is a little hard to see. You know what? I think I'm just going to solve this by hand. This is easy enough. So let's solve this by hand. Yt equals 20 minus t times 1 minus cosine t. Okay, so if I set this equal to 0, what do we get?
So first one, so t is 20, but it should be less than 20, so cosine t should be 1, so it should be pi over 0 and 2 pi, yeah.
Okay, hold on. So pi over 0 is undefined. Where is the cosine equal to 1?
1, 0 and 2 pi.
Okay. 0, 2 pi. Okay, that's 0. So that's 2 pi. And this one should be... I need one more.
3 pi? No, 4 pi.
4 pi. Okay. So which zeros are we looking for? There are 2 times between 0 and 18, so it's not including 0. So the times we want are 2 pi and 4 pi.
So it's
Okay.
next 2.
Then they asked us to find the average speed between those 2 points. So how would we find the average speed?
Oh, that's f prime 4 f4 prime no f4 pi minus f2 pi divided by 4 pi minus 2 pi.
So my problem with that is we don't have a function in terms of one variable, we've got a function in terms of two variables.
Mm-hmm.
So that could give you average x of t maybe, and then average y of t.
Average speed.
Hmm.
Oh, and then no.
Okay, we've got an equation for speed already, so is there a way that we could use that equation for speed to get the average?
Oh, divided by 2 pi.
Okay, so that's my first part. I'm going to divide by 2 pi.
Oh, and then integrate.
That's it. From what to what?
2 pi to 4 pi.
2 pi to 4 pi of our speed equation.
Yes.
Okay, so this is my average value equation. We're using it for speed. X prime of t squared plus y prime of t squared in terms of time.
Mm-hmm.
Okay, and do not evaluate the expression. We could substitute those in, but I think that's pretty much it.
Mm-hmm.
Awesome. Alright, I think I'm actually going to end there, and we'll save the next problem for the next class.
Mm-hmm.
There's a number of free response questions to try on your own with parametric equations over the weekend.
Mm-hmm.
So if you take a look at the classwork document on Skype or WeChat, you'll see those. Any last questions before we leave? Any last questions before we break?
Oh, no.
Alright, have a good one.
Bye-bye.
Goodbye.